I am taking bit, it's okay. So, I mean, once you do groundwater modeling, so it requires a lot of data set. And one of the primary data is that water table contour map, which we will try to do today. And secondly, how to generate a 3D model which depicts or which imitates the real field, a structure or geometry of the aquifer, if it is single layer or multi-layer, right? So from where we will get this data? So data for aquifer geometry. I am talking about the data of aquifer geometry. Aquifer की geometry हम कैसे construct करेंगे? Who will answer?
The litholog data.
Good. Yes. Very good. So, litholog से करेंगे. First, I want to cover one topic in theory, and then I will move on to this litholog section in the lab class. So, is it okay to continue, or shall we wait for other warrior to join? See, let me complete this topic in theory, and meanwhile the others will join us, and then we will start the lab class. And to tell you, you should focus more on lab classes and the applied aspect of it. You can ask questions related to the lab. So we were talking about site selection for bridges, and we covered up to the depth to bedrock, right? Depth to bedrock in geology is the most influential factor that will decide the location. And if the location is not changeable, then you need to go for geotechnical correction for a sound foundation, right? So foundation को correct करने के लिए you need to do the geotechnical test and then civil engineering. Seismically active zone, right? So this again, this becomes this is a kind of threat. This is additional threat that you are doing construction of bridges in a seismic active zone. So be it a bridge or a high rise building or any other construction, so always you need to uh, you need to coordinate with the seismic mapping of that area, which seismic zone the particular area is falling. So if it is seismically active, the foundations are required to be designed for additional seismic loads as specified in the code of respective areas. So seismic zones के codes बने हुए हैं. If you are working in that area, so you need to. Now, in glaciated areas, special care must be taken to establish the existence of drowned or buried valleys that might filled by secondary material of most heterogeneous character. Because in glaciated areas, the only way to know about the lithology is by drilling, right? So if you have unconsolidated layer or the formation overlying the comparatively consolidated rock, then that gives a heterogeneity. Right now, the thickness of that first unconsolidated layer will affect the construction design of any project, be it here we are talking about bridge. So उसमें जो foundation होगी, again you need to take special precaution. So, what kind of precaution? In such cases, a bedrock may be encountered only at greater depth. It may be desirable to reach it through piles. Right? वहाँ पर piling करनी होती है. Piling is a big job in geotechnical field. Uh, okay, so now that was site selection, and we are moving now to EIA, Environmental Impact Assessment for a bridge. So the component of EIA will be the same, with the addition that you have more and more. You see here the hydrology and hydrogeology. So geophysical and geotechnical tests and slope stability tests. These things you will include, or these things will be the key inclusion while in comparison to the other projects, right? Rest of the things will remain same. That first you will go through the environmental laws and legislations of that country or the state, and you need to align with. Okay, जब हम बात कर रहे हैं that component of EIA, now you think yourself as if you are doing EIA reporting. So EIA रिपोर्टिंग के लिए एक टीम होती है, राइट? सो उसमें एक टीम लीडर होता है. टीम लीडर के अंडर में बहुत सारे ऑफिसर्स होते हैं, जिसमें कि सॉइल, ग्राउंड वाटर और जियोलॉजी को देखने वाला एक ऑफिसर होता है. ठीक है. सो यू नीड टू बी मोर फ्लेक्सिबल so that you can accommodate soil. Although you are from geology, you need to accommodate soil. You can go, you can look around the rainfall runoff modeling, which is the pure hydrology, right? So you can also uh, take care of rainfall runoff modeling. Okay, geology you would do, hydrogeology you would do. Again, geotechnical tests. So for that, you need to be more flexible, that which what kind of geotechnical tests are to be done, because most you can do, you can supervise drilling or drill cuts or the cores that are coming out. Now you can take those drill cuts into any geotechnical laboratory for any specific tests. Okay. Again, biodiversity is altogether a different sphere. So there are specialists in the team who look around for biodiversity. Biodiversity means how the fauna and flora is getting affected by that particular activity or project. So finally, the main one of the main component of EIA is to develop the baseline status of the environment, right? So in all sphere of environment, soil, water, biodiversity. So all the baselines, air quality. So baseline is established so that now any offset or is done from those baselines, so it will be compared in future with those baseline established. So these baseline will become a legal thing, that the project has a negative impact or positive impact. So for that you need to compare it with the baseline, right? So that's why for all EIA, now remember this, for all EIA you need to develop baseline status of all spheres of the environment. So, being a water expert, you are responsible for groundwater, surface water, soil, and geology. So you will have baselines of all these. So how the baseline is done? How the baseline is done for groundwater? Baseline for groundwater or surface water is done with, you know, with monitoring. For example, first you will monitor the water table, right? For quite some time, you will try to capture if there is any dynamics change, any prior to project. This is EIA phase, right? Uh, and what is the water quality? So before the project, for example, water quality was very good, and within the construction, now you come to this, during the construction phase something happened within the project premises, overturning or accident or some spillage, right? Or the material interaction of water with the material. So, and because of that, the groundwater quality turns bad. So it can be compared with the baseline. So if baseline is missing, you cannot compare with the baseline, and you cannot say that this is because of this activity. So what comes out here, that within the EIA you need to develop the uh, extent of work within construction phase. Now, because EIA is nothing but prior to construction, what is the environmental conditions? Now you are making a plan for construction phase, right? So in construction phase, what may be the requirement? So that you need to list down within EIA. सो ये ऐसे हो गया जैसे आज आप EIA कर रहे हैं, लेकिन आफ्टर 6 months वंस द EIA इज डन, कंस्ट्रक्शन विल स्टार्ट, राइट? लेकिन कंस्ट्रक्शन में क्या क्या रिक्वायरमेंट होंगी, उसके क्या क्या यानी इम्पैक्ट्स हो सकते हैं, दैट टू यू नीड टू इंक्लूड इन द EIA फेज. नाउ एनवायरमेंटल परमिट्स एंड क्लियरेंसेस, आप एक्सटेंट ऑफ कंस्ट्रक्शन और उस कंस्ट्रक्शन में क्या क्या मटेरियल चाहिए होगा, व्हाट काइंड ऑफ परमिट एंड क्लियरेंसेस यू वुड रिक्वायर, दैट ऑल यू नीड टू पेन डाउन विद इन द EIA. नाउ अब ये 1 साल या 6 महीने आगे की बात है, बट स्टिल यू आर कंसिडरिंग और यू आर having all details of that within the EIA. Details of work item and risk involved in each construction activity. Details of work done, geotechnical, constructional, survey and testing, change in natural condition. Change in natural condition means, for example, if excavation is required, so how much volume of excavated material will be generated. So natural जो विनीर था, नेचुरल जो लेयर था सॉइल का या अनकंसोलिडेटेड सेडिमेंट्स का, दैट इज बीइंग एक्सकवेटेड, राइट? will it be used within the project area, or you need to dump it somewhere? So for that you need to have a clearance as well. Material requirement and types, mitigation and management, checklist, and finally, as a responsible environmental engineer, you need to have a monitoring plan during construction and after completion. So very first thing what you did as a for the monitoring, you did baseline. After baseline, you are monitoring during the construction. During the construction, you did not stop, but you are continuously monitoring the water table, water quality, be it surface water or groundwater. And similarly, air quality monitoring, right? So this baseline during construction and after the completion. So this is how an efficient EIA should include monitoring plan. Now, similar to that, we have another topic: environmental impact of water impoundment. So quickly we'll go through. Water impoundment is nothing but this is naturally or artificially constructed water body. Sometimes you may call it lagoon or reservoir or just pond. Why it is required to have environmental impact of this water impoundment, right? This is the question, and for the answer we are having this topic, right? We are discussing this topic now due to potentially harmful effect of water development in some areas. यानी द वाटर डेवलपमेंट और जो वाटर इम्पाउंडमेंट हुआ है उसका इम्पैक्ट जानने के लिए ऑन द रेस्ट ऑफ द एनवायरमेंटल जो डोमेन है, बी इट सरफेस वाटर, ग्राउंड वाटर, सॉयल और in the neighborhood, in the vicinity, or biodiversity, right? So this water body, depending on its location, this may have harmful effect on rest of the environment. So this need to be taken care of, and that's why the environmental impact assessment is required for such water impoundment. Now, decisions regarding whether to make it or not must be based on sound investigation of both long and short term effect of reservoir construction and operation. जैसे मैं बहुत ही यानी आपको इजी वर्ड्स में बताऊं, such water impoundments sometimes used by different departments, right? I would not name, but in my previous job profile, one of the department, they were using it to throw their waste material, liquid waste material, right? So this is one, of course, one type of example, but I mean there could be several issues. For example, it may harm the water quality. So very first thing you will include what is the water quality of this water impoundment, and what how it will interact with the groundwater, or how it interact with the existing surface water bodies if it is, right? And depend what will be the extent of impoundment, that means how much area will be impounded. Impounded का मतलब समझ रहे हैं, मीन्स कितना एरिया इनंडेटेड हो जाएगा, पानी से भर जाएगा, inundated हो जाएगा, how much area will be inundated. So that means that area, that much area will be excluded from city planning, right? And this, what will be the thickness or the volume of water, and how it interact with rest of the environmental domain. So this you need to establish within the EIA, right? So what is the water table in the vicinity of this water impoundment area? Is it going to join some surface water body in future, or what are the temporal changes? If this can sufficiently accommodate the rainfall runoff, or there may be danger of flash flooding because the area do not have the capacity to receive surface runoff generated by rain in some particular month, right? Whether this there is a chance of this water impoundment being used by some other entities for I mean both in positive or in negative way. Negative way, as I just explained. Positive means okay, this can be used for storing water for some time by treatment plant, right? That is valid. Okay, so treatment plant can take this amount of water in the time of water deficit, right, and can purify and use it for the city for the household supply, but they should not do the reverse. They should not throw their wastewater and use it as a wastewater dump. अच्छा, ये सारी चीजें हो गई। एक डोमेन हमने बहुत इंपॉर्टेंट भी डिस्कस नहीं किया है, एंड दैट इज इन्वेसिव स्पीशीज, and this is quite interesting, and I would like you to just read about the invasive species in aquatic or water impoundment. Invasive species, basically, let me that means all flora and fauna. A thorough description of the plant and animal to be affected by inundation should be made to determine the possible loss of rare or key organism as well as potential development of nuisance species. Now, as I said in the beginning, make yourself a little bit flexible and accommodative. We are talking about ecology, we are talking about biodiversity, right? सो वो जो एरिया था जहाँ पर इम्पाउंडमेंट हुआ, उस एरिया की नेटिव स्पीसी क्या थी, नेटिव प्लांट और एनिमल स्पीशीज क्या थी वहाँ की, ठीक है। दिस नीड टू बी considered during EIA, and how it will be affected by the water impoundment positively or negatively. Second thing. Third thing is, because this is becoming a water body, there will be outside species. We call it nuisance species. Nuisance species, or we also call them invasive species. So invasive species are those species which are not native, which come from outside, right? And sometimes they are harmful for the native species, right? फॉर एग्जाम्पल, बहुत ही सिंपल एग्जाम्पल आपको समझाने के लिए, यहाँ पर वो थे, यहाँ पर लोकल पिजन्स की स्पीशी थी, but because of this water impoundment, there are some hawks or eagles from outside. They came and start residing in this area, became a threat to the local birds. So this way you will go ahead with your environmental impact assessment of water impoundment. So this we have discussed already, that you need to develop a rainfall runoff model, because at the regional scale, you need to know what is the position of this water impoundment, whether this is at the upstream side, and the upstream higher altitudes, right, or it is at the downstream or midway somewhere, right? So in all the cases, you need to have a rainfall runoff model, so that you can tell that water will be added from the next rainfall event and will not cause any havoc to the neighborhood, right? For example, if this is a river, right? So river will be flooded. So this is a normal flood in normal rainfall season, normal monsoon season. Impoundment A area will be flooded. But if there is more rain than usual, there will be impoundment B, right? So what is the relationship of the new artificial impoundment area with the surface water body? This need to be reconstructed, so that the flooding impact should not multiply, राइट। पानी वहां पहले से ही था और फिर रेन की वजह से रन ऑफ और ऐड हो गया उसमें, सो दिस विल मल्टीप्लाई। सो एंड मल्टीप्लाई मीन्स दैट इट विल नीड नाउ मोर surface area. So more surface area means it may ingress into the housing community, So that for that loss of life and property, you need to cover it up in environmental impact assessment. Now इसी से मिलता हुआ एक न्यू ब्रांच हो जाता है विच इज कॉल्ड लिमिनोलॉजी. Now limnology is these days this is quite in demand, and limnology is the understanding the properties of impoundments and how they relate to natural bodies of water can help us to define this. I mean, in limnologies में क्या है that जो भी inland lake artificial or natural, either reservoir, river, stream, wetland. So you try to develop a relationship with the groundwater and rest of the biodiversity. So this is an integrated study basically as ecological system interacting with their drainage basin and atmosphere, right? So hydrology is like you are studying the dynamics of a surface water body, but limnology is way ahead. It added into the interactions with the environment, right? Groundwater, adjoining area, wetlands, right, and the biodiversity. So this is a new branch emerges from this, which is called limnology. So limnologies पर भी बहुत PhD positions निकलते हैं in European countries especially, where you study water with the new flexible way while interacting with rest of the environmental domain. The limnological discipline integrates the functional relationship of growth, adaptation, nutrient cycle, and biological productivity with species composition, and describe and evaluate how physical, chemical, and biological environment regulate these relationships. So this is bit concise definition of limnology. Okay, so with this, I think I end up the theory class. I will move on to the lab class. In case you want to ask something in the theory class, ask it now, or I'll move. Okay, can we move? Okay. Screen is shared. Okay, so I have uploaded these exercises 0 to 4 or 5. I don't know. So I think there is you are not facing any problem in this. You know that how to draw water table contour map, right? So we have depth to water table map and water table contour map, and there is a difference, and you know that difference. We'll try to so how many of you have done this? किया है किसी ने?
फर्स्ट एक्सरसाइज की है कंटूर वाली, उसके बाद अभी कर सर्फर से कर रहे थे, अभी सीखा नहीं था तो कल पहला किया है.
नहीं, सीखने जैसी उसमें कोई चीज नहीं है. उसमें I told you already that you need to prepare one Excel sheet, right? So वो Excel sheet, I mean the surfer will ask you for this or any other software, be it ArcGIS even. right? Or you can do by hand as well in the meanwhile. Don't stop yourself because we have to move ahead. Okay, so water table contour map for pre-monsoon, right? And this water table contour map for initial time, this is a primary requirement of modeling exercises. Wait, I will. So वाटर टेबल कंटूर मैप के लिए जो डेप्थ टू वाटर है उसको उसको माइनस करते हैं, राइट? किस तरह से वाटर टेबल कंटूर मैप प्रोड्यूस होता है? हु विल टेल मी? अस्का? जो
स्टडी लेवल से लेंगे, वाटर लेवल
व्हाट व्हाट जो वहां का एलिवेशन है, जो वेट अ मिनट, आई थिंक यू ऑल नो दिस बट आई जस्ट the last time or last the final time I want you to clarify this. सी, ये जो आपका सरफेस एलिवेशन है यहाँ पर, दिस इज लाइक 215 मीटर AMSL. What is this AMSL?
Above.
Above mean sea level, right? So, and where is the mean sea level here? Mean sea level, and why mean sea level? Okay. Yes, I have asked a question. Why mean sea level? Who will answer? Equipotential surface. Okay. Yes, yes, yes. You are right. Who will add something? What is this basically?
So it is the base level, sir, afterwards, sir.
See, mean sea level is the, as the name is explanatory, it is mean sea level extending into the inland area. Mean sea level, तो sea level sea पर होगा, ठीक है? Now you have a geoidal surface. Geoidal surface is the equipotential surface where if you allow seawater to come into the inland area, it will have the equipotential or the surface which will erase out the topography and depressions. I mean the altitude and depressions. This will erase out the topographic impact on water table, right? Now, अगर हम सरफेस को रेफरेंस बनाते हैं तो उसके क्या नुकसान हैं? उसका
अंडुलेशन से
सरफेस को अगर हम बनाएंगे तो ये एक लोकल रेफरेंस होगा, ठीक है? ये एक लोकल रेफरेंस होगा और आपके 100 मीटर पर कोई वेल है, उस केस में यू मे बी राइट, but if it is kilometer away, you may not know what is the how the surface topography is changing, right? So depth to water takes into account the topographic elevations or depressions, or take into account the topography, right? While water table contour map nullify or erase out the topographic impact or topographic elevations or depressions or topography, right? Because this is constructed on a regional or a global reference, which is mean sea level. And mean sea level, as just now we discussed, it is the geoidal surface of sea level extending into over the globe, right? अब उसमें ये जो डिप्रेशंस होंगे या एल्टीट्यूड हाइट होगी वो नलीफाई हो जाएगी, राइट? सो व्हेन आई से 215, this is basically this, and 215 is the point where you are your the top of your casing, top of your well casing is there. So this is 215, and this is basically the depth to water. This is depth to water, right? अब इसका reference surface से है, ठीक है? Now what you are doing in water table contour map, here at this point, you are measuring the height or elevation of the water table. Okay. So if this is 15, for example, if this is 15 meter BGL, right? So how much will be the water table elevation?
200.
Okay, so this is 200 meter AMSL. Now all these values, once you converted water table contour map, and this also can be done, if you are working on a raster file, right? So you just make, we can do that, uh, one raster of topography and one raster of the depth to water, and you just do the subtraction, you will get the this surface, which is water table contour map. We'll do it now. For that you need to, in very first row, you need to have the titles. What is the value stand for, or this is also called attributes, right? So very first row, or the very first cell should be description of the items it contains. For example, this is 215. Okay, so I mean this is elevation. So very first thing is ID. ID is nothing but, is it visible, right? ID is nothing but the IDs of piezometers. XY is nothing but the latitude, longitude of the area, or those piezometers. And this is topographic height. Topographic height. Let me make a, give me a moment, please. Actually, I'm having one parents teacher meeting today, so and this is reference height. And what is reference height? You all know reference height is the height of the casing which is coming out or above the surface. Now, depth to water pre-monsoon and depth to water pre-monsoon, this is reduced level. Reduced level means now you just minus out reference height from the your reading, so that you will get this from the surface level, right? So how you will get the water table contour map is elevation minus depth to water pre-monsoon reduced level. Okay, so this is how you will get. Okay, now we'll try to make the contours of you don't need to color it, I just want to highlight to show you. So we'll make against this one contour water table contour map for pre-monsoon. Okay, and we will make one for this and one for elevation. And I'll also try to show you how we do the raster math or raster calculations. Actually, we have more things to do. Okay, so this is the base map, and how to make a base map you all know, and if you don't know, then you should try to just get in line how to make a base map. Okay, so working on the base map, you want to include here now you will this goes to that file which you saved, right? And you know the location. Now it is asking for x, you need to give it x, y, you need to give it y, and column c is the attribute, the value you want to highlight or you want to do contouring for that value. So what is that value? Water table contour map, the last one. Okay, and here you can set the limit. I need to write it down. ये जो इंफॉर्मेशन यहाँ दी हुई है x0 maximum 627 662 spacing, so all this should be uniform in another raster file so that you can do the raster math. If this is not same, you cannot do the raster math. So make sure that your geometry is same. So that's why I'm writing it down. Now it is easy for me actually. 630, 660. This is nothing but x maximum and x minimum, right? Yes, please. So with this, we made this contour map. You want to give me something or what? Okay, ठीक है. So now this way we constructed the contour maps. We can go and we can give it quickly. Okay. So now, who will tell me about groundwater flow direction? So this is very simple thing. Groundwater flow direction we can know from the equipotential lines, right? It will be flow line will be perpendicular to the or direction will be perpendicular to the flow line, right? This we know from our previous classes, right? Okay.
Yes.
Okay. Ab there are many things actually we can study or we can take out, we can infer from this map. The very first thing is the boundary conditions, right? Okay. Now if I zoom in to this area, what you observe in this area? This one.
This is hill like.
Right? What is this? And there is an opposite character which is in the
This
neighborhood.
would be the recharge area and the discharge area.
This will be the
Recharge area.
recharge area because the contour pattern is such that the highest contour in the middle of the circle, right? The middle in the middle of this concentric area, the middle contour or is greater, while in the top the middle contour is smallest. So this will be the discharge area, or this is the cone of depression, right? And this is the mound. This is the recharge area. So, and what are the causes? What are the reason why we have mound and the cone of depression? Certainly, there could be some surface water bodies or something which is having, recharge in the form of seepage. Here we may have pumping, or by any other means there is a discharge area. So this is how you see. This is how in 3D it looks like. See the recharge areas look like a hillock, while the discharge area looks like a depression. Okay, this was all about the water table contour map. एंड वाटर टेबल कंटूर मैप किस तरह से ये होता है, रेफरेंस इसका क्या होता है, ये वी ऑल हैव डिस्कस, सो देयर शुडंट बी एनी कंफ्यूजन इन फ्यूचर नाउ ऑनवर्ड, राइट. डेप्थ टू वाटर का रेफरेंस क्या होता है कुमेल? डेप्थ टू वाटर का रेफरेंस क्या होता है?
सर
Okay, so we'll do it. You try doing this, and we are done with the contouring or hydrogeological mapping part. Now we are moving to the lithological logs, right? Because we need to. Okay, you are given a construction project and you are doing the drilling, right? During the drilling, you need to record the drill cuts and the lithology. I mean, based on drilling, coring. So you make a record of the subsurface information encountered with respect to depth, right? So these are called lithologs. अच्छा, इसका फॉर्मेट कुछ इस तरह का होता है that you can, I mean, you will have as much as information you can. For example, latitude, longitude, और इसका कोई of course the name ID, right, and the location name and the project name. So all this includes into, and once you are working with some contractor, they may have a small software or something to represent the litholog. So on the left hand side, this is the litholog, and the litholog is the representation of lithology. On the right hand side, you will see the well construction design, right? So this is how you need to prepare a well completion report. So this is part of well completion report. ठीक है, ड्रिलिंग का कोई भी प्रोजेक्ट आपको मिलता है, सो ये मैंडेटरी होता है दैट यू नीड टू प्रिपेयर अ वेल कंप्लीशन रिपोर्ट. वेल कंप्लीशन रिपोर्ट का एक पार्ट ये होता है दैट यू नीड टू डू द लिथोलॉजी एंड वेल कंस्ट्रक्शन डिजाइन. सो कल हम बात कर रहे थे जो टॉप पार्ट है उसको सीमेंट कर देते हैं, राइट. सो दिस, if this is not cemented, as in case of private wells you see in your neighborhood, so this area get vulnerable to the receiving contamination anyway. But here what we are doing, we are going through the lithology. So ab aise lithology you need to have it for all such points. If you have it for all the points, then you can either by contouring or by different software, for example rockworks or other softwares, you can draw the hydrogeological cross section, right? So hydrogeological cross sections किस तरह से बनाते हैं वो एक्सरसाइज आपको हम so these were the three well drilled in a line. So using these three lithologs, you can draw a lithological cross section, right? So how you will do? Of course, you will scale it. So this will be the vertical scale. This is the vertical scale with respect to mean sea level. So यहाँ पर you will graduate it. For example, 215 till 150. Who is this coming up now? Mohammad Mushir? Mafi Faida Alhin. You are too late. Okay. Just आपको शो करने के लिए I'm just quickly. Okay. So इस तरह से you have here, and because you know all information about this litholog as we discussed here, so you know the information, right? This is 0, and 0 means what is the elevation here? 11.30. That is, it is quite near to the sea beach, right? So only 11.3 meter above mean sea level. Okay. So I need to change it actually. Okay, अब इसमें यहाँ पर you need to check what is coming up in the beginning of it is sandstone. Okay, from here now you have some clay within, then again you have sandstone till bottom, right? If it is sandstone, you can show it. I mean, you need to do it by hand, so don't worry about. And this is clay, right? In the middle, you are getting clay. Okay, you have the same kind of sequence, but here you see that the sandstone was quite thin and the clay become thicker, and then further you have the I mean, Okay, so this is the sequence you got in three of the drilled well in a line. Now you can join these three wells, join these three. Now here it is not extending, right? So you need to stop it somewhere. Okay, so this way you will have your hydrogeological cross section. And if you have multiple wells, that means you have sufficient wells sufficiently covering the area, you will have the data to construct a 3D model, 3D geological model of your area. Okay, we call this cross sectional image hydrogeological cross section. And if you include multiple wells, if you include more wells into this current setup, I'll show you. These will be properly positioned, right? These wells will be properly positioned as depending on their XYs, right? So now for this we were the bottom one we were telling the cross section area. Now it will become the fence diagram. That means now you know the aquifer geometry, and you can just make a soft file data, and using that you can prepare the 3D model, right? Okay, so this is very important exercise in a manner that once you go for the big things like groundwater modeling. So in groundwater modeling, you need to conceptualize the area. So once conceptualization means what, I'll tell you. So this, for example, so you need to have the raster layer of first elevation and the bottom of the, see, this is first layer, this is second layer, and this is third layer, right? So you need to have the top and bottom of each layer, right? So in that manner, this is very important. Okay, that is the applied aspect of that exercise. I will upload it onto your Google class. I mean the litholog exercise. Earlier I had already uploaded those for water table contours, and with this I end up the class. Though we may continue, but I have to go somewhere. Okay, is that fine?
Yes, sir.
कुछ पूछना है अब्दुल खालिक, यूसुफ जई,
No.
Azka? Please have me the attendance and you may leave. Maassalam.